Okay, welcome to this video lecture. Sorry for the audio quality for those of you who watched the first one, replacing it with this one. So I want to pick up where we left off talking about C++ I/O, and we had previously talked about using cin and cout as well as creating our own input and output files, opening them by using the iStream and the OStream objects. Now I want to talk about when we're dealing specifically with input, how we can deal with input failure. And input failure could be the result of there not being input available. It could also be the result of us trying to read something that's not the right type for what is in the input stream, whether that be, again, from the keyboard or cin, or whether it be from a file. So when we attempt to read from one of these C++ streams, input streams, whatever they are, the extraction operator, or any of the functions that we've talked about using, like Getline and stuff, attempt to read a value into the variable that's indicated. If there's a conversion available, so if the data that's there isn't exactly the right type, for example, if there's a whole number there and we're trying to read into a double or a float, so there's a typecast or a conversion available, then the extraction operator will attempt to convert that value to that variable. If there's not a cast available, so for example, we're expecting an integer and there's a string there, like some characters which aren't convertible, then what happens? And what happens is the input operation fails, and the stream itself, the stream value or the stream object, has a failure indicator or a flag set. And so we need to find out how we can access that and how we can use it to control our input, and also how we can eventually clear it so we can go on with reading additional things from that same stream. So one of the things that's clear then is when we design our flow of control, our code for doing input, that it's important that we not only understand the data that we're going to be reading in and understand its format, but that we also account for the fact that there may be stream errors, especially when we're dealing with keyboard input, because we don't control what the user is going to actually do, regardless of what we requested. So we have to handle those particular situations. So we're going to talk about how to do that in most of the remainder of this section. So let's consider, for example, this program. And if we look, there's several variables declared of various types, int and double and char and string. And then we're looking at some different input scenarios from the stream in, which is, again, this is a code snippet, so we don't see where it's actually declared, but it's an input stream, probably from a file. And then in the comments next to each line, we're seeing what the possible stream data looks like. And in this first case, we're expected to read an integer followed by another integer, IA and IB. And we see there's a 17 and then an X. So IA should be set to 17. The X, however, is a textual character, which we can't convert to an integer, at least not using standard conversion type conversions. So there would be an error on that in stream, and we need to know how to retrieve that. And we'll see how to do that in just a minute. In the second example, we're reading two doubles. Now in this case, the 73 could easily be converted to a double, so it would be, even though that's maybe not what we intended, that's in fact what would happen. Of course, the point 2 does satisfy the requirements to be a double. In the next case, we have an integer, so the 73 is fine, followed by a character, which the dot would satisfy, followed by an integer, and we'd get the 2. That may not be what we intended, but that would certainly satisfy all the criteria. In the next case, a character, followed by a double, followed by a string. So for the character, we could certainly read the 4. That would satisfy a character, certainly in an ASCII character set. And then for the integer, we would get, or the double, we'd get a 2, which can be converted to a double. And then for the string, we would get the 2-3 Bravo X-ray, which would certainly satisfy the string. In the next example, very similarly, the integer would capture the 42, followed by the character, which would capture the 2, because remember, it's a single character, and then 3 Bravo X-ray would satisfy the string. So again, maybe not what we expected to get from this input string, but it certainly would satisfy the request. So what happens when there's a failure? So there's actually true-false flag set on the stream itself, and we can use that to check whether the operation failed, which means we could use a while loop, for example, using that input stream failure to drive the while loop. But we also need to then what we call, some people call priming the pump, or in this case priming the read, or priming the loop, if you will. So we need to do a first read of whatever the data is that we're expecting, so that the while loop will then be satisfied the first time we do the test, because remember, while loops test at the top, and then in the loop we can do additional reading, and of course we do the read at the bottom after we process the current input. And we'll look at an example of the wrong way to do that in a minute, but first we'll look at some examples of the right way. This is a very, very common pattern in programming. We've certainly used something very similar to it in C. And we do these kinds of things over and over because most programs have some sort of input that they have to deal with, whether it be from the user or from a file. So this is a very common pattern when we have repetitive input. So let's look at this example. Now in this example, you'll see there's actually three parts. There's the code snippet, which is not the complete program. There's an example of what the input looks like and then what the output looks like, so we can kind of see what's going on. So in this example, after the variable declarations and initializations, the first thing that happens right here, about a third of the way down, is we read in the first time value, which is just an integer which represents time in minutes. And then we do a while in, and notice in is the stream. So what we're checking is to see whether it's true or false. So if it's true, we'll keep going. So if the very first read was successful, we'll keep going. We'll process the time value, in this case converting it to hours and minutes, and then writing it out. And then at the bottom of the loop, we read another one. So the first time we would have read the 217 in the input, processed it, turned it into 3 hours and 37 minutes as we see in the output. And then at the bottom, we would read the next one, which is the 49. Since that would be a success, we would continue when we got to the top, the while loop test, and then process that and get the 0 hours and 49 minutes, and then continue in that fashion until we read the last one, the 198. We read the 198 at the bottom, we'd go up, we'd process it, and then when we try to read again, there would be a read that would try to occur, but it would result in end of file, which would be an error on the stream, if you will. So when we get to the top, the while loop would fail. So we drop down to the line of code below that, which is another output, which writes out the total time. We were accumulating that in the total time variable, and writes that out in minutes. So that's the intention of what the program is supposed to do. Keep reading until there's no more input, and then provide a final summary output in this case. So that would be the proper use of sort of this pattern of priming the pump or priming the read up here at the top, processing the data, reading again at the bottom, and continuing to test until we've reached the end of the input. Okay. Now, what if we had the same program? So you might have to refer to the previous slide. But now the input, somewhere in the middle here, had an XXX, which would be 3 characters, which would not read as an integer. So what would happen? The program's still going to terminate gracefully. In other words, it's not going to blow up, segmentation fault, any of that kind of stuff. But what's going to happen is after we read that 110, at the bottom we do a read of the XXX, that's going to be a failure because we were unable to read something that looked like an integer. So at the top, when we do the while test, there will be a false. We'll drop down to the bottom, we'll print the results. And so it processed all the input that it could until it reached an invalid input. But if we knew, for example, that the input had 6 lines or 7 lines or whatever it has, we would know that looking at the output that something had happened, it exited prematurely, but at least when it exited prematurely, it did so in a graceful fashion. And we'll find out in a minute how we can also include a test in here to let us know that it terminated before it reached the final end of all the input. In other words, there were some values after that XXX. We'll find out how to fix that as well, and we could do an appropriate error message, and we'll see how to do that in just a minute. Okay. Now, here's an example of the wrong way to do this loop. So this is how we would not want to do it. Even though it looks like it works, we get the wrong answer. And sometimes, I know on homework assignments, even on labs, we do this where, well, it looks like it worked, it executed the right number of times, but we don't take the time to check and see if the answer was appropriate. So when you design your test cases, be sure that you're checking not only did it execute the proper number of times, did it execute without having some kind of catastrophic failure, but it also gets the correct answers, because if it's not getting the correct answers, it's still not a useful program. So in this case, you'll notice there's not a priming read at the top. So what happens that very first time when we do the while loop? Well, in fact, if we've just opened the file, there's no error on the stream, so it would go ahead and process the while loop. But what if there had been a previous set of operations that did some reading from that file, in this case in, and in fact had ended by having some kind of an error condition, read some invalid or something? Then the input stream would have a false flag on it that there'd been an error, and this entire loop wouldn't execute, so we wouldn't get the correct answer. So we might luck into it working, but as we'll find out, it's also not going to get the right answer. So as we look at this one, the first time it's going to read the 217, and so it's going to get through the while loop, hopefully, in other words, the test at the top. It's going to read the 217, it's going to process it, and then it's going to come back up at the top, and since the 217 read properly, we'll keep going. We'll read the next value, 49, etc., etc. What's going to happen, though, is when we get to the 198, we're going to read it, we're going to process it, we're going to come back up to the top, and we're going to have a true, but then we're going to try and do a read. We've already read the 198, so now we're at the end of file. So in fact, the input stream now has an error on it, but we're going to process it again. But since there was an error, the value of time didn't change from the 198 that we previously read, so it's going to process the 198 again. And you can see in the output the 3 minutes and 18 seconds that the 198 minutes represents is repeated. So in fact, we're end up including that value twice. So it looks like it executed properly, but it read 8 values instead of 7, or it shows that it did. And in fact, it processed the last one twice. And this is a very subtle error that if you're not careful, you can make, and it'll look like everything's working okay, when in fact it's really not. So be sure you're using the pattern correctly. Be sure you're doing that priming at the top if you're going to use this type of repetitive read situation. Okay, let's look at a couple other examples of other kinds of I/O that we might use on a stream. Getline, which is a function similar to one we've used before in the C library, but this one is slightly different. It's going to work off of a stream object, but it does have a similar look to Getline. So we're going to pass it 2 parameters, the input stream, in this case we're going to call it iFile, and then a string to put the information into. And the thing about this is it's only going to stop when it hits a new line. So it's going to read the entire line even if there's embedded white spaces, which doesn't happen when we're using the regular extraction operator with a string variable. So in this case, we'd read the whole line. The first time we'd read the Fred Flintstone laborer 13301, and then it would stop. Now we could have done this with a stream variable or with a stream regular extraction operator, but we would have had to have 3 string variables because it would have stopped after the space or the tab or whatever the white space is that separates Fred Flintstone from laborer, and then it would have stopped the next time we did a read because of the white space between laborer and the 13301. So we would need 3 separate strings to read those in, and if that's what we wanted, certainly we could do it that way as well. Now there's also, as we'll see here in a minute, there's another way that we can use Getline. So Getline's always going to read from the current position until it hits a new line, or whatever the stop character is. So sometimes we don't necessarily want the stop character to be the new line. And remember, of course, when we read this, anything that's the whole line is read, so if there's leading white spaces, those will still be included and stuff, which the extraction operator doesn't include. If we want to specify a different stop character, for example, a tab, then we can include a third parameter to Getline. Remember, we've talked briefly, and we'll be addressing this more, that in C++, we can have what are called overloaded functions, where they can have different numbers of arguments with the same name. So if we had a third parameter, we can specify the character that is going to indicate the stop of the reading for the line. So we could use tabs, we could use the X character, whatever single character you wanted to specify that's supposed to stop the reading of the line, we can specify that. The default is new line, but we can change that by adding that third parameter to the Getline function. So in this example, using the same data file that we had before, now I've got 2 strings and an integer. We're going to treat that third value as an integer, not as a string. But now we're going to read the name and the job title and the employee ID separately. We could do that with Getline by changing the stop character to a tab, because that's what separated those three fields. So we could read the entire employee name, so the comma and the space in the middle of the Fred Flintstone would be read together, which we wouldn't have happened if we were using the extraction operator. So it would read up to the first tab, which would get me the name. Then it would read up to the next tab, the second get line, which would get me the title. And then we're using the standard extraction operator to read the int, which would read the value. And then it would stop when it hit the new line still. And then we could ignore everything from that point on. So if there was something after the employee ID, even though it looks like in the data file only it was white space or a new line, if regardless of what it was, if there was anything else on that line, using the ignore at the last line of code that we see here, we're basically ignoring anything left on that line up to the new line, up to and including the new line. We're just throwing it away. And the int max there is just a constant that's a sort of a predefined one, that whatever the biggest integer you can represent is, which would be different on a 32 or 64-bit machine. It would read that many characters or the new line, whichever comes first. So that's just a big number, basically. And those limits, there's also an int min, etc., are in that climits header file, which is included up at the top of the program. Okay, so here's another example. Then here we're just finishing up that code and printing out the information and then reading it again. So remember, we primed the pump by reading those three values at the top, and now we're doing the exact same two get lines and then extraction operator inside the loop to continue reading until we've read all the information in the input file. And in this example, there were just 2 lines in the input file. And then we're done, we're closing the file, and then we're done with the program. Now, one of the things we talked about earlier was what if we hit one of those lines where there's some invalid data, but there's still more stuff left in the file. So we want to be able to check to see if there was a failure or not. And we can do that with the fail member function on whatever the stream is. So in this case, we've opened the stream, and of course, one of the things we always want to do when we open a stream, is we want to make sure that we were able to successfully open it. Otherwise, we're going to go on and do reading, but we're not going to read anything. So we can check the stream to see if there was a fail flag set, and if so, we could print out appropriate information and then terminate the program or do something else, whatever we would do in the case that we weren't able to open the file. In this case, the message says file not found, which is usually the reason why an open would fail. Either we provided the wrong name, or it's not in the right folder, or whatever. And then we do whatever else we need to do and then close the stream in this case. But we could also use that to help us determine, for example, when we've ended reading a certain kind of input, but yet there's still more stuff in the file. So let's consider an example here where we're going to use the fail, but we're also going to use something called clear, which is another member function. This lets me reset the status flag, so it sets it back to true, if you will, so we can keep going. After a failure has occurred, we've acknowledged the failure, we've recognized it, we've done whatever processing we need to do, and now we want to continue on. So we need to clear that flag. And we can't do that simply by closing and reopening the file, as the note says. We need to actually do a clear. So let's say we have an example where the data file is some text. It's for a baseball player. In this case, it's some statistics. And we've got some labels that just tell me what the columns are, hits and at-bats. Then some data that's columnar data. And then the player's name. So after a certain number of this information about hits and at-bats, we're going to have the player's name. But there may not always be the same number of lines of those hits and at-bats. So we need to know how many we processed, and then we need to be able to recognize the fact that we've terminated that input, but we still have another line that we need to read with the name, so we can't just end the program or the loop at that particular point. So what would happen is we'd be reading, looking for 2 integers. When we hit the name, there would be a fail state. So we need to check for that fail state, but then we need to clear it so we can go on and read the name. Otherwise, we never would be able to do another read on that input stream. So let's see how that works in a program. So in this program, we've got our data values declared up at the top. So we've got the file being open, hitting.data is our file. We've associated it with a stream name called in. And then we've got some variables declared for the player name and the hits and at-bats and etc. And then some variables to accumulate how many hits and how many at-bats. Then we're going to, the first actual read there is ignoring that first line, which were just the labels. So we're just to ignore that first line up to the \n. We don't need to read the labels in this case. Then we're going to start reading the hits and at-bats. So the first line here is our priming the pump again. So we read the first set of hits and at-bats. And then while that's true, in other words, while the stream is true, while we've read a valid line of 2 integers, we're going to keep going. We're going to accumulate and then do another read. So this loop here on this part of the program is reading those sets of numbers, however many there are, and we're going to accumulate a count of those and accumulate the number of hits and the number of bats, and then we're going to read the next one until we hit a fail. But once we hit a fail, we're not done. Remember, there's that player's name after that. So we go down to the next part of the program. So there's a failure. So we knew there was a failure. Now we're going to clear that failure because we came out of the loop as a result of the failure. Now we're going to clear it, and then we're going to read the player's name, which is done with a Getline. Then we can calculate some statistics, the batting average in this case, and then we can write all that information out. So we used the failure to terminate our loop, but then we needed to clear it so that we could go on and do more reading. If we didn't do that clear, that Getline would fail as well because there's still a failure on that input stream. So we haven't cleared that yet, so we'd still not be able to do anything. Now, sometimes also we want to be able to check, for example, and see, have we reached the end of file or not? In other words, we had a failure. I remember back in the example when we were reading the times and there was the XXX in the middle. So how could I check to see if me terminating the loop, the failure that caused me to terminate from reading those times, was an error in the data or was actually the last time data value in the file, in this case, or in the stream? Well, we can do that with another member function called EOF. EOF will tell us if we're actually at the end of file. So if we are, it will return a true, otherwise it will return a false. So for example, in that previous example, if after writing the output, we could tell if we were at the end of file or not, so we knew if it was a complete processing by checking EOF. If we weren't at the end of file, like in this case it's saying if not in.eof, then we print out an error message saying, hey, we didn't reach the end of file. An error occurred while reading the file. We didn't reach the last record. So this time information that you're seeing here is incomplete or incorrect. So this way we would use that. Now, the tendency here is to try and take a shortcut and say, I can use EOF, so I'll just check if I'm at EOF to terminate the loop. The problem with that is we don't want to do that because we may have a failure before we reach EOF, but our loop would keep going. So in that previous example, if our loop checked for EOF only, then when we hit that XXX, we would have read it, not processed it, so not forwarded the file pointer past that point. And then when we did the loop, we'd go back to the top of the loop and say, we're not at the end of file yet, and we'd try to read it again. We'd basically start trying to read that XXX over and over and over without moving forward. So we'd end up with a never-ending loop. So it's always good to use the failure and then check to see if the failure was as a result of hitting EOF or not. So we know whether there was a problem or whether it was the natural termination of the input. Another function that is occasionally useful is get. If I want to read just a single character, this is similar to our getchar or getch function that we had in the C libraries. So we can use whatever the stream is. In this case, the example is cn. cn.get, and then some char or some char would need to be a character variable declared as a single variable, and then a single character. And then I can read from various streams and individual characters if I need to. A couple other useful functions you might occasionally need to use. Sometimes you want to peek ahead at the next character to see how you want to process it before you actually consume it or actually read it and move the pointer that's keeping track of where we're at in the data file ahead. So we can do that with a peek. It returns the next character but doesn't actually consume it, so it doesn't move the file pointer forward. So we can see what it is without moving. If we had gone ahead and done a get, for example, we'd read that character instead of doing a peek, and then we realized after we read it that we needed to do some special processing, like maybe it was a special character like a question mark or something like that, then we can put it back, and put it back is kind of like a rewind. Basically says, rewind the file pointer back one character, put this character back into the stream, and then move the pointer back to where we're pointing to it again. So again, sometimes that's useful. If you remember back when we were doing C, one of the examples was writing our own version of of a get double without using the library functions, and so it had to go through and basically look ahead to see if the next character was the period, or read it, and if it was the period, put it back, so that because we know, like in a floating point value, when we reach that period or that decimal point, then we change how we do the processing of the letters or the numbers as we read them, because after the decimal point, we're not multiplying by 10, we're dividing by 10, for example. So that's another useful function as well. This brings us to the end of this section on I/O. Apologize for not being in class today due to a funeral, but hopefully this video lecture will finish up what we need to talk about on I/O. On Thursday, we'll have class as usual, and we will be talking about some other C++ things. We'll be continuing our discussion of both non-object-oriented C++ and the improvements and benefits it gives us over C, and then also we'll continue our discussion of object-oriented code as well. I do remind you that this week is the lab test, so be sure you attend your lab session this week. And also remind you that your homework is due on November 1st, which is at the end of this week, homework 4, and then you can start working on homework 5, which we've already discussed, and we'll review also on Thursday. If you have any questions, I'll be in my office for office hours on Wednesday, and certainly, as always, you can reach me by email. Thanks for listening, and I will see you on Thursday.